सर हारून आ रहे हैं छुट्टियों पे आपको कोई मालूम?
कल शादी है तो शायद.
Okay, so now today we will study how we can interface different devices to a microcontroller or a microprocessor. We are defining some parameters that what we are interfacing. We want to interface keypad with an LCD, and in between there is a microcontroller or a microprocessor. Okay, so within the keypad there are three registers. Are available. One is SR, one is CR, and one is DR. SR stands for status register, CR stands for control register, and DR stands for data register. Status register, control register, and data register. Similarly, the same type of register are available in an LCD, which stand for SR, CR, and DR. Okay. SR means that the status of the device. Now let's assume if some device is interfaced with the microprocessor, so within that particular I/O device, there is a status register, and it actually tells the microprocessor whether it is ready or not ready. So we assume that now when SR is 1, the value of SR is 1, it means now the device is ready. You can perform a read or write operation on that device. When it is 0, it means that it's not. Similarly, for control register, when it is 0, so it means now we have configured that device as an input device, and when it is 1, so we have configured that device as an output device. So now we have a configurable type of an I/O interfacing. We have a configurable I/O interface. In a configurable I/O interface, it implies that I/O can be either configured as an input or an output based on the contents of the control register. So if the contents of the control register is 0, so what does it imply? Now the device can be configured as an input device, and if it is 1, then it outputs. Now there is also one register, data register, and in data register, so now in the context of the keypad, so now we have one data register. In one data register, it implies that now whenever a user presses a key, so the ASCII code of that key will go into the DR. Okay. Now similarly in an LCD, whatever is stored in the DR, that will be displayed on the LCD. Now, if you look at the context of the LCD, so actually if you look at an LCD, so LCD may have multiple DRs. Because if you look at an LCD, there are some block boxes. Maybe there are 2 rows and 8 columns. So how many digits can be displayed? 16. So it means 16 characters can be displayed. So actually there can be multiple DRs. DR1, DR2, DR3, DR4, DR4, and so on. But for the sake of simplicity, and whenever, if you look at the LCD, there may be other configuration register within an LCD. Maybe there is one pointer that is pointing to the current cursor location, which you want to write some data on the LCD. So maybe within an LCD, let's assume you have this LCD. There are different 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you can display different characters. And let's assume the current location is here. So maybe this is also stored in some different register. Okay. And whenever some data comes into the data register, that data will be displayed here. Okay, and then you can have an auto shift policy. In auto shift policy, whenever that data is displayed, it will automatically shift to the right side. So there are also some controlled commands. And you can give these commands that you want to move the cursor right or to the left. You can move it in the upward direction or in the downward direction. So there can be some kind of more and more internal registers within this LCD. Okay, so there can be multiple registers, there can be multiple data registers, and there can be multiple control registers. But this is only one status register that means that now the LCD is ready or not ready. But now we want to write a very simple program. We want to write a very simple assembly language programs. So we want to configure our device. So we start with the main. So now this is our main program. So we start with $org $2 $4000. So it means now This instruction will be compiled at which locations?
400.
Okay, so now this is the starting program. So now I'm writing it main. Main is now the start of the program. Main is actually a label. Main is actually a label, and it is the address of the first instruction. It is the address of the first instruction. Okay, so now if it's, we can also call it main, or we can also call it config. Can we do it like this, config? Config, because we want to do some configuration. Okay, now if you want to configure this device, if you want to configure the keyboard as an input and LCD as an output, which value should we move into the control register of keypad? G, what should be this value?
0.
Control register 0, and what will be this value?
1.
1. So this is our first objective. This is our first objective. Now we want to configure this device. Okay, but we can also use it like 0 or 1. But we want to make our program more readable. We want to make our program more readable. So can we write it like this? See, input equal 0, output equal 1. It's the same as define in C++. You have used define? In C or C++, you have used it define in mnemonics. So input equals 0, so config. Config, we want to move 0 to the control register. What is the address of this control register? $002. Which addressing mode we will use?
That's just immediate.
It is the address in memory.
Absolute.
Absolute addressing mode. The addressing mode should be on the left hand side or right hand side?
Right.
Left hand side, because we want to configure. So move $2002. Okay, now we want to make our program more readable. We want to make our program more readable. $400 is the start of the program. So we can also write it like this, config. We can also write it like this, move. We can write like this, move $2002 hash 0. Is it? Am I right or not?
Yes.
No, sir.
Why?
Sir, you 1 bit का register.
No, even when so if the value is 0, it means even if it's multi-bit register, we are not considering it's a 1-bit register. But when its value is 0, it means it's configured as an input. Okay, can I write it like this?
Yes.
So actually, this value of 0 will be moved here. So now the keyboard is configured as an input device. But now we have a better idea. If we write it like this, we say that CR of keypad equal $2002. So if I replace this instruction with like this, move
CR keypad
hash 0 input.
Yes, sir.
Now we are using echo command. So actually whenever it's input, whenever it sees input, it will be replaced with
0.
0. When it will say CR keypad, it will be replaced with
जैसे सर मैटलैब में जैसे हम वेरिएबल इनिशियलाइज करते हैं इनपुट इज इक्वल टू 0.
It's labeling. This program is more readable or less readable?
मोर रीडेबल.
More readable. More readable. So actually we can use it like this, move CR keypad hash input. Now we are configuring. Now we want to configure LCD as an output device. How we can write? Move what?
उधर लिखेंगे LCD
CR LCD equal what?
3002.
We are using absolute addressing mode. CR LCD hash. Now if our specification changes, if we say that it is 1 and it is 0, so what we need to change? Here we need to
echo की
change.
जगह वो change करना होगा.
What is the advantage of echo? The advantage, I'll explain to say advantage of echo. Now let's assume if you have some program and you say that count echo 100. Count equal 100, and you're using some compare count with 0, and then you're also using count here, add R3 hash count, and if count has been used at 100 places within a code, a count has been used 100 places. So if you change the count to 15,
सारी जगह पे changes आ जाएंगे.
the changes will be done automatically. This count echo has two advantages. First, it improves the readability of the program. Second, it provides you to maintain a good maintaining of the code. Less modifications are required in the code. And it's more easy to write a program. It's human readable, and the code is easily maintainable. Okay. So now output. So it means that now it has been done. This operation has been done. This has been done, and now it has been done. What is our objective? Our objective has to check the status of the keypad when some key, or when the user presses a key, so this SR will be 1. This SR will be 1. It means that now the user has pressed a valid key. So now what we have to do? First, we need to move this. What we can do? Move R3. You are using some register R3. We are moving this key, and now we are also defining some SR keypad equal
200.
SR keypad $200 and ready equal, what is the code for ready? 1. Move R3. What we are moving in R3? SR keypad. Which addressing mode is this? Absolute addressing mode. SR keypad $200. This value will be moved into which register?
R3.
So now, when R3 is now your destination, now we have to compare. Compare R3 with ready. What we are doing? We are comparing R3 with 1. When R3 is 1, so it means now some valid key has been pressed. Some valid key has been pressed. When valid key is pressed, so what should we do now? We should scan the input. So we can say scan. Now, but if it's not ready, it should again check what? Check the status. So it has to check the status. So we can say, we can define some status which is called as wait. So compare R3 with ready. When it's not equal to ready, so branch not equal wait. Understood or not? Any question? If you have any question. So what we are doing, compare R3 with ready. Now in ready, actually it is equal to #1. When it's equal to 1, it will jump on here. If it's not equal to 1,
वापस wait.
it will be wait, and it will continuously check the status. Microprocessor or microcontroller will continuously check the status of the LCD. So when the user has not pressed the keyboard, it will be status, it will be 0, 0, 0, 0, 0, 0, and actually it will be in a continuous loop. Whenever the user presses a key, it will become 1. When it becomes 1, this condition will be false. When this condition will be false, control will automatically transfer to scan. And now it's scan. Definitely we have to write some instruction. So now what? Now we are moving this DR.
Data move करेंगे LCD पे.
So move. Okay. Now we can use some temporary register R4. Maybe we can use some temporary register R4, comma DR.
उधर
DR keypad. But then we can define as DR
keypad echo
keypad echo
2004.
2004. DR keypad. Whatever the key is pressed, maybe its S key value it comes in here. So when SR is 1, it means now a valid key has pressed. Let's assume the user has pressed A. So when the user has pressed A, so maybe the SC code is 65. So 65 will move in here. So now what we are doing? Now we have moved this 65 value into which register? R4 register. Now we want to, but now we need to check the status of the LCD. Whether LCD is ready or not ready. So again we have a wait. We can use the same thing. Move R3. Now R3 has been used. Move R3. SR LCD. SR LCD. SR LCD is defined here?
No sir.
SR LCD equal
$3000.
SR $3000. So it again moved into register R3. Then compare R3 with ready. Compare R3 with ready. Okay, now we not ready because there is a different weight, so maybe weight 2.
Sir, why do we need an intermediate register like R3? Why can't we just compare SR LCD with the?
You can do this. You can directly use the absolute address. It depends on the microprocessor or the architecture. Some microprocessor does not provide comparison on a memory location. Some microprocessor does it. If the microprocessor does not do it, so you have to do it like this. If it means that your point is very good. So actually, what we can do, we can replace these two instructions
In a
single instruction. So it's a very good point. So we can replace these instruction in the single instruction. So how we can directly write compare SR keypad
#ready.
Which addressing mode is this? SR keypad $200. This is absolute addressing mode.
Yes.
Some microprocessor provide this and some microprocessor does not support this. So it varies from microprocessor to microprocessor. Some microprocessor does not allow comparison directly on a memory operation. If it does not allow, so you have to use this one. If it allows, you can use this methodology. Okay? So the code size is reduced now. Instead of 2 instructions, now you require a single instruction. Okay? So now scan back to, now why you cannot use the same label? Because then there will be an address clash. Because this weight, what is this weight? This weight is actually an address of this instruction. Understood? Okay, now compare R3 with ready. Again, branch not equal. Wait 2. Now you have already the data in register. When it comes out of the loop, so output. So you can define another label output, and now we can move now in this dr LCD R4. Now R4 has the ASCII value of the key that was pressed. You can directly move in there. So there is a complete like set of the code. So now this is a small set of the code that first check the status of the keypad. If the status is 0, it will be in a wait. If the status is 1, it means that the device becomes ready. Then it will read the value from the data register. And this configuration is done only once at the start of the program. This configuration is done at the start. Once it's done, DR LCD R4 you have displayed in.
सर ये configuration ORG से पहले नहीं होता?
No. I will explain this. Okay. Jump output. When it's done, so you need to repeat the same process. So do we need a conditional branch instruction, unconditional branch instruction? Unconditional. Where? To configure to wait. Wait. The config has been done only once. Done? So it means jump. Jump where? Wait. Now I will answer your question. Now if you look at the memory map of this, program, so this program will look like this. It has a memory map. Memory map starts with an address $4000. This is an instruction I1. I1 will be stored here. And let's assume the size of the instruction is 4 byte. At $40002, so 004, which instruction will be stored? I2. Then I3 is here. What will this address? 400C. Which instruction? I3, I4, I5, I6, I7, I8, I9, I10, I11. So I5, I6, I7, I8, I9, I10, and then I11. There are 11 instructions in the program. Now $400C, $4010, $4014, $4018, $4001C, $4020, $4024. So these are different memories. So if you look at here, so the address of the config label is this. So config is pointing to this. The address of wait is this. Wait is pointing to this instruction. And what is the address of scan? What is the address of output? Now if you look at this program, so actually now you are jumping on wait. You are jumping on wait. We are jumping on wait. So this is your current program counter. Okay. Now this is jump instruction. This is address of jump. So this is actually address of jump. Am I right? Address of jump. This is actually address of jump is actually the address of this instruction, that is I11 instruction. When this I11 instruction, how the offset will be calculated? Offset is actually between the address of jump and the wait. So the difference of this, so the difference of address of jump is $4024 minus $4008. So this is actually what? The offset field of the instruction. So if you look at this jump instruction I1, it has two fields. One field is opcode, another field is offset, and as offset is this. Okay? So now we have written a small program. small program. And this small program actually scans the status register of a keypad. And which addressing mode is used? The status register, and if it's checked whether it's ready or not. If it's not ready, it will be in a wait state. If it's ready, it will jump out of this wait state. Then it will enter into the scan mode, and in the scan mode, the data will move into some temporary register within the microprocessor. Okay, when it's done, then you will again continue to check the status register of the LCD. If it's not ready, it will be again in the waiting state. When it comes out of the waiting state, it will come out of the loop. Then again the output is moved to the DRDR register. Then we have to scan another input. Okay. So now this is how it will be done. Now we will write a small C program. Now we have some C program, and then we have to write an assembly code for this. So actually, how does a C program is translated into an assembly program? So we will study that how we can transfer a small C program, okay, into an assembly program. No issue? उठा दो? Okay, so let's assume we have this program void main, and we have int test, scanf, %d, and test. It's just like cin. Scanf is just like equivalent to cin. Okay. So then we have some switch statement and test, and then we have exit. We have this case test is equal to 55. We have some code 1, and then we have break. Then case test is greater than 55. Then we have some code 2, and then break, and now we have some default, and now we have some default code. Okay, so now I think so this program is very simple in C. So actually it's first use, so which